GMAT all day.
So now we are getting into the more advanced combination questions. This question is a combination question involving probabilities. Not all combination questions are probability questions, and not all probability questions are combination questions, but they are related. And so it is good to know when you can use your combination knowledge to probability type questions. And there will be a whole series of videos on probability later, so you can check those out whenever you want. For now, let's see how they are related in this question here. A fish tank contains 6 crabs and 4 lobsters. If a seafood platter contains 4 shellfish randomly selected from the fish tank, what is the probability that it contains 2 lobsters? So if we start out by doing the same framework that we've been using, first question is, does order matter? Am I picking a team or am I running a race? Here, I am picking a team. I am picking a team of 4 shellfish. So order does not matter, as is usually the case with combination questions. And then the second thing I like to do is I want to write out my pool of people, or in this case, shellfish, that I have to choose from. So I have 6 crabs and 4 lobsters. I got crab, 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 crab. I need to get like a crab and lobster emoji or something for this. Then I got 4 lobsters. Lobster, 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 lobster. So this is my pool, and I am choosing 4 of them. So to see how probability and combinations are related, let's start by saying, let's suppose you had someone who didn't really know anything about combination questions, but they probably do know something about probability, because probability is more ubiquitous of a concept than combinations. So let's say how someone might approach this question. So we are looking for the probability of a seafood platter that contains exactly 2 lobsters. So one thing someone might do is they might just say, okay, I'm going to write out an example of what my seafood platter can look like. And so I got 2 lobsters, and it says exactly 2 lobsters, which means these final guys here must be crabs. And so then they might say, okay, so when they say exactly 2 lobsters, what they're really saying is a seafood platter that contains 2 lobsters and 2 crabs. And then they say, okay, well, if I can just find the probability of picking each of these guys one after the other, then I can find the probability of picking this entire platter, because this here would be an and scenario, because I'm saying I'm picking a lobster and then another lobster and then a crab and then a crab to make up my seafood platter. And so in and scenarios, you multiply your probabilities. So I'm just going to find each of these probabilities and multiply them. And so here I am picking a lobster. So to start, I have all of my shellfish available to pick from. And so I have 4 lobsters out of my 10. So I should have a 4 out of 10 chance of picking this lobster here. And then once that lobster is chosen, I have 9 shellfish left. Only 3 of them are lobsters to choose from. So I get a 3 out of 9 chance of choosing a lobster here. Then here I have 8 shellfish left, and here I should have 7 shellfish left. But now I'm picking my crabs. So of these 8, 6 of them are crabs. And then once that first crab is chosen, I got 5 out of my remaining 7. And so this is the probability for picking this platter here. And now if I reduce my individual probabilities and multiply them out, let's see what I get. So 2/5 times 1/3 times 6/8, which is 3/4 times 5/7. And now I'm going to use my divisibility knowledge to make my life easier by canceling stuff out. These 5s cancel each other out. These 3s cancel each other out. This 2 and this 4 leaves me with just a 2 down here. And I get 1/2 times 7, which is 1/14. So according to this, I would have a 1 out of 14 chance of picking this seafood platter, which is an answer choice C. And the question is it the right answer choice? Unfortunately, though, it is not. Why is this not the right answer choice? Because so what did we solve for here? We solve for a probability, but it is not the right probability, because we are looking for, we said order does not matter. Therefore, we are looking for all of the different ways I can choose 2 lobsters and 2 crabs. And when or I should say when this hypothetical person wrote out this example here, they did not write out all of the ways that you can choose 2 lobsters and 2 crabs. They wrote out one way. They wrote out lobster first, lobster second, crab third, crab fourth. So that is one possibility. But there are other ways I can get 2 lobsters and 2 crabs. I can have lobster, crab, lobster, crab. I can have lobster, crab, crab, lobster. I can have crab, crab, lobster, lobster. I can have crab, lobster, crab, lobster. Or I can have crab, lobster, lobster, these are literally all of the different ways I can get 2 lobsters and 2 crabs. And each of these is going to have a probability of 1/14. And so now this is individually, these are and scenarios, but now I have an or scenario because I can get 2 lobsters and 2 crabs this way, or 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 this way. So in or scenarios, you add your probabilities. So this would just be 6/14, which is 3/7. And that is the right answer, A. So now I know what you were saying, but we did not get to use any of our combination questions, our combination knowledge when we did this. We just sort of brute forced all of the different ways you can get this combination. And on your actual test, you might not be able to do that. Say there were 20 scenarios or something. You would not want to draw out all 20 of those scenarios. So you should probably know how to relate combinations to probabilities so that in a scenario like that, you don't have to do that. So if we start thinking about this in terms of combinations, well, we can start by saying, okay, so they're asking me for a probability. Therefore, they're asking me for a fraction with a numerator and a denominator. If I can just write out what that fraction is in words, I know exactly what I need to find more to look for. So here I need how many of my platters have 2 lobsters and 2 crabs. So a good place to start usually is with the denominator with probability, because that's the easy thing, because all probabilities are just some subtotal over some total. And the total is usually the easier thing to find. The subtotal, that's going to be the thing they're asking for. So my total is just my total possible seafood platters. And I want to know, out of my total possible seafood platters, how many of those, so the number of platters with 2 lobsters and 2 crabs. This should give me the probability of choosing a platter with 2 lobsters and 2 crabs. So now I just need to translate this top and this bottom into blank, choose blank statements. And like I said, it's easier usually to start with the bottom, the total. So the total possible seafood platters I can make, I have 10 shellfish in my tank, and I am just choosing 4 of them to be on the seafood platter. That should just be 10, choose 4. So now the top, this is the thing where you have to think about. So how many of those platters are going to contain 2 lobsters and 2 crabs? And so like in the choir example we did, this is sort of an order doesn't matter, but with subgroups. So I'm picking one team of 2 lobsters and then one team of 2 crabs, and then I'm putting them together to form a 4-person team of 2 lobsters and 2 crabs. So how many ways can I choose my 2 lobsters? How many lobsters do I have to start? I got 4 lobsters in the tank, and I'm choosing 2 of them. So 4 choose 2 should be the number of ways I can choose my lobsters. And then how many crabs? I have 6 crabs, and I'm choosing 2 of those. And so because any 2 of the lobsters that I choose can be paired with any 2 of the crabs that get chosen, we are multiplying here. And so our answer should be 4 choose 2 times 6 choose 2 times over 10 choose 4. And as far as I'm concerned, this is the answer. Someone can write this out. They are 90% of the way there. Everything else after this is sort of like, just don't make a math mistake. And so the first thing I usually do is I usually start with the denominator, because usually what that means is the denominator in our answer choice either has to be what we come up with here or a factor of that, a simplified version of that. And so sometimes you can, if you're short on time, you can eliminate answers quickly by just getting the denominator. So what is 10 choose 4? That should be 10 factorial over 6 factorial times 4 factorial. So that's 10 times 9 times 8 times 7. Everything after this should cancel out with your 6 factorial, leaving you just with this. And so 4 times 2 is 8. That gets rid of that. 9 over 3 just leaves you with a 3 up top. And we're left with 10 times 3 times 7, which is 210. So now I have 4 choose 2 times 6 choose 2 all over 210. And if we want to see, can we eliminate anything from our answer choices? I believe this we can sort of eliminate because we so that's not the answer. 21 and 5 both are factors of 210. This is not. We can eliminate B. Now let's find, so how many ways can I choose my 2 lobsters? That is 4 choose 2, which is just 4 factorial over 2 factorial times 2 factorial. So 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1. So these cancel out here. We're just left a 2 times 3 up top, which is 6. We got 6 times 6 choose 2 over 210. Now we just got to find what 6 choose 2 is. 6 factorial over 4 factorial times 2 factorial, which is 6 times 5. Everything after that cancels out the 4 factorial. This should just be 3 times 5 or 15. So we got 6 times 15 over 210 should be our answer. What is 6 times 15? Either 80 or 90, I believe. 90. So 90 over 210, which is 9 over 21, which simplifies to 3 over 7, which, as we sort of spoiled before, is the correct answer. And so this is why I like this problem, because in this case, I can write out all of the possible scenarios in which I get 2 lobsters and 2 crabs. And so I can sort of show behind the scenes what you are doing when you are using your combination formula. But you will probably not be able to do this for every single one of these questions. So you probably want to be able to set it up using your combination knowledge. If you can do this, this is the important part. This is what matters. Everything after that is just arithmetic. So let's do one more combination question. In the next video will be a combination question with restrictions.